work on solving radical equations and how the process goes for solving. So in the ultimate, then what we want to be able to do is we want to be able to find the value of x or y, or find the variable with that. In order to do that, we're going to go through really a four-step process. And it's always kind of the same process when you're solving radical equations. Whether they're going to be linear solutions, like you're going to have today, or quadratics, like you're going to have tomorrow. So first thing you're going to do is you're going to isolate the root. Okay, so we're solving radical equations. We're looking at solving square root problems or cubed root problems or whatever. First thing you have to do is you need to isolate the root, meaning it needs to be all by itself. So if there's any addition or subtraction being done to it, you need to get that to the other side of the equations. If there's any multiplication or division being done to your radical, you need to move that to the other side of the equation by multiplying or dividing or doing whatever it is you need to do. Once you've isolated that root, the next thing you need to do then is you need to, if it's squared, you need to square both sides to get rid of the root. If it's the cubed root of, you need to cube it. If it's the fourth root, you need to take it to the fourth power, and so on and so forth. But you need to, we'll just say to keep it simple, you need to square both sides to get rid of that root. So when you square a root, they kind of cancel each other out, leaving you just what's underneath the radical. And then you square the other side and get 175 or whatever. But you square both sides. Next thing you have to do is you have to solve for x. So at that point, after you've squared both sides, you should either have a linear equation or you should have a quadratic equation. If it's linear, find the value of x. If it's quadratic, set it equal to 0, then factor. We're not going to do any quadratics today. Everything we do today is going to be linear. And then the last thing you have to do, and this has to be done, is you have to check the answer. Because sometimes you get answers that don't work. Okay, so if I had something like find the square root of x equals negative 25. Well, you got a square root that's going to equal negative, and that's not going to have a solution. Now, you would find a value of x that looked like it worked, but it actually doesn't work. So you always need to check the answer when you're solving radical equations. So again, the 4 steps: isolate the root, meaning get it on its own side, get everything else on the other side. Square both sides to get rid of the roots, solve, and check the answers. All right, so now it really becomes about just looking at different problems and performing those steps. So our first problem, we've got 5 plus our root. The square root of x plus 1 is equal to 16. So step 1 says to isolate the root. So I'm just going to highlight the root. So I need to get everything except for the square root of x plus 1 to the other side of the equation. So I've got 5 plus. That plus doesn't really mean anything, but I've got 5. So this means I need to subtract 5 from both sides of the equation. Now that I've subtracted 5 from both sides of the equation, I'm left with x plus 1, the plus sign out in front of it, don't really need that anymore, is equal to 11. So I've got step 1 done. I've got my root isolated. Step 2 says square both sides. Because we're taking the square root of x plus 1, we're going to square both sides. Squaring gets rid of the square root. When you square the square root, you essentially get what's left underneath the radical, x plus 1. 11 squared is 121. So step 1, we isolated. Step 2, we squared both sides. Step 3, we need to solve for x. So we solve for x now. We subtract 1 from both sides. You get x is equal to 120. So step 1, isolate. Step 2, square. Step 3, solve for x. We got our x value at 120. Now we check it to make sure it works. We put 120 in. 120 plus 1 is 121. The square root of 121 is 11. 11 plus 5 is 16. That's good enough for checking. You don't need to show it. You just need to make sure you work yourself through it. And we've got our solution. And we're done. Questions with the first one? Second one. Ooh, oh, that's right. We've got 6 times the 4th root of n plus 2 equals 12. Okay, so step 1 is to isolate. So I'm going to locate my root. This is the 4th root, so there's my root. This is showing multiplication of 6 to my root. So we get rid of multiplication by dividing. 6 divided by 6 is 1. So I'm left with the 4th root of n plus 2. 6 divided by 12 is 2. I've got it isolated, so step 1 is done. Step 2 is to square both sides, but we're not squaring it. We're taking it to, we're doing the 4th root. So to get rid of the 4th root, we take it to the 4th power. Whatever root you're taking, you take it to that power. We're left with n plus 2. 2 to the 4th power is 2 times 2 times 2 times 2, 4, 8, 16. We've isolated. We've taken it to the 4th power. Now we solve. Subtract 2. N is equal to 14. We check it. 14 plus 2 is 16. If you did the 4th root of 16, the 4th root of 16 is 2. 2 times 6 is 12. It checks out. It works. You move on. Isolate, square it, cube it, whatever you need to do to it, solve it. Check it. Next one. Multiple things now going on with this one. One, we've got it on the right-hand side now, so that tends to confuse people. Again, I'm going to highlight what I have to isolate. So now I just stop and think for a couple seconds. I've got 7 being added to it, and I've got 2 being multiplied by it. Okay, just treat this as if it was like a variable in itself. It's 2 times the highlight plus 7. So when we're solving an equation, when we have 2 times something plus 7, we subtract first. So we're going to subtract 7 first from both sides of the equation. Minus 7, minus 7. Yuck. So that's 19. So 19 equals 2 times the square root of x over 10. It's not going to be a whole lot of fun, but we'll be fine. Now what? Again, this is highlighted, so just think about this as 2 times a highlight. How do you get rid of 2 times a highlight? Divide by 2. Fractions are ugly, but they're okay. Just leave it as 19 halves. That's going to equal the square root of x plus 10. So we've got our highlight isolated. There's nothing being multiplied by it. Nothing else going on. Okay, the fraction is underneath the radical. Next step is to square both sides. Siri, what's 19 squared?
18 squared is 324.
Siri, what's 19 squared?
19 squared is 361.
So that's 361 over 4. Remember, when you square, you have to square both the numerator and the denominator. That's equal to, oops, we took care of that by squaring it. We're just left with x plus 10. Now what? Solve for my variable. So my variable is being divided by 10, so I have to multiply both sides by 10. That leaves me with x. It's a great number. I'm going to make this a 5 and this a 2. Hey Siri, what's 5 times 361?
5 times 361 is 1,805.
Yuck. And if you get a fraction like that, it's probably right. Checking that would be a nightmare. I promise I won't do that. I should have made that an 8. That would have made life a lot easier. But I didn't, so we just did the fractions. Do you understand the process? Okay. What happens if you have something like this? So we have 3 is equal to b minus 14 to the 1/3 minus 2. So in this case, this right here, that's an exponential form. The best thing you can do with this is rewrite it. So remember, when you have something that's an exponential form, like this is, to rewrite it, this becomes the cubed root of b minus 14 minus 2. So you can rewrite it. Now it looks like a problem that we just kind of got done solving. So anytime you got something that's a fraction, especially if it's 1 over something, rewrite it this way. It makes life easier. Go ahead and finish this off. See if you can finish that off. Isolate the radical. In this case, then cube each side. Solve for b and check it. Give you 2 minutes and 10 seconds. Nope. We're gonna move this down to 1 minute. 21 minutes. 1 minute and 12 seconds. And I think we've got one more to look at, and we'll call it good. All right, let's take a look. What first? What do I do first? Add 2. So 5 is equal to the cubed root of b minus 14. Now what? Take the cube it. 5 cubed. 5 times 5 is 25 times 5 is 125. 125 is equal to b minus 14. Add 14. 139 is equal to b. 139 minus 14 is 125. Cubed root of 125 is 5. 5 minus 2 is 3. It checks out. It works. Okay. Questions with that one? What happens if you have something like that? A little different. So we have the square root of x plus 2 is equal to the square root of x minus 6. So it looks a little different. We don't have anything being added or subtracted, and we've got 2 separate radicals. Ideas. Square it. If I square both sides, very good. If I square both sides, as long as I do both sides of the equation, if I square both sides, I'm left with 7x plus 2 is equal to 3x minus 6. Now we've got something that's linear. And that's exactly how you do it. Now we have to solve. So I'm going to subtract 3x from both sides and subtract 2 from both sides. So 7x minus 3x is 4x. 2 minus 2 is 0. 3x minus 3x is 0. Negative 6 minus 2 is negative 8. X is equal to negative 2. Does that solve my equation correctly? So negative 14 plus 2 is negative 12. Negative 6 minus 6 is negative 12. So the square root of negative 12 equals the square root of negative 12. That's true. Okay. So it works. In this case, it works. But again, you got to be a little bit careful when you get negative square roots. But in this case, it works because they both are negative 12. So the whole goal today was to be able to solve radical equations. Remember, when you're solving radical equations, isolate the root first. Square, cube, or do whatever you have to do to both sides to get rid of the root. Solve for x. Check your answers. Any questions with day 5? Worksheets right there. The answers are inside of Schoology. Get to work.